So what is an ellipse? An ellipse is one of the four conic sections. It's basically when you cut a cone at a specific angle, you'll get an ellipse. And so how does or what does it look like? So it looks like this. Okay, so if you cut a cone at a certain angle, you'll get this shape right here that we call this an ellipse. Now an ellipse has many parts. Okay, let me show you the parts of an ellipse. So here you have the first part, of course, is the center. Okay, so the center of an ellipse, let me use another color. So that's the center, and then you have your vertices. Okay, so your vertices are those that are in the endpoints of your ellipse. But your ellipse could be elongated in the horizontal direction or the vertical direction. But your vertex will always lie at the end points of your ellipse, where it is longer. Okay, so that is a vertex, and the points, the end points of the ellipse where it's shorter, that's your co-vertices. Okay, and then your focus is also on the direction of your vertices. Okay, and then this line or axis where it is longer, okay, so the longer axis is called the major axis, and the shorter axis is called the minor axis. So your vertex, your focus lie on the major axis. Okay, now let's look at this other ellipse. This is oriented vertically. So again, your center, your vertices, and then your focus are all in the major axis. Okay, so this is the major axis, and then your co-vertices lie on the minor axis. So that's basically, these are the parts of an ellipse. Now the ellipse has an interesting fact or characteristic that is unique to itself. Okay, let me show you what I mean. Okay, so say this is your ellipse, and say that this is your focus, or these are your foci or your foci. Okay, the interesting thing about an ellipse is that if you choose a point anywhere in your ellipse, so let's say let's choose this point right here, and if you draw a line from that point to your focus or your foci and add the lengths together, say this is d sub 1 and then this is d sub 2. If you add d sub 1 and d sub 2, you'll get a constant value, you'll get a number, right? But then if you choose another point, you pick another point, say this point right here, you connect, you sort of measure the length between the two foci and this point, and say name this as d sub 3 and d sub 4. If you measure those, the sum, okay, if you add d sub 3 plus d sub 4, you're also gonna get c. Whatever this value is, you're always gonna get a constant value. Okay, say you pick a point that's here. Okay, see this point right here, and then you connect these 2 points and this thing, and then you add, say this is d sub 5 and then this is d sub 6. If you add d sub 5 and d sub 6, you're still going to get c. Okay, so this is a constant value if you add these 2 things right here. Anywhere you look at it, any point that you choose, you're always going to get that same value. So that's the unique characteristic of an ellipse. Now before we end, let's discuss the equations of an ellipse. So an ellipse has 2 equations, so it depends if an ellipse is horizontally oriented or vertically oriented. So in the case where the ellipse is oriented horizontally, the equation would be x minus h squared over a squared plus y minus k squared over b squared equals 1. So this is for the horizontally oriented ellipse. Okay. Now we also have a vertically oriented ellipse. Its equation is x minus h squared over b squared plus y minus k squared over a squared equals 1. So this is for a vertically oriented ellipse. Now what's the difference? The difference lies in a, because in both equations, a is always greater than b. So if the greater value in the denominator lies under the term where you find the x, then that is a horizontally oriented ellipse. That means the ellipse is stretched in the x-axis. If you find a in the term where you can also find y, then that means that the ellipse is stretched vertically. So you'll get a vertically oriented